With that, we are going to transition into the next session, which is about aircraft metering, time, speed, and spacing. And it's going to pick up on the discussion that was just occurring, because so much of the use of PBN is so dependent on this topic. So with that, we've asked Fran Hill, who's the Senior Vice President of Transportation Solutions from Leidos Innovations, to moderate the panel. And I think it promises to be a very interesting one. So with that, Fran?
Thanks. Thank you. I'm so honored. Thank you so much, Andy, for your intro. In case any of you all are wondering, and this will save me another 10 questions at the break, Leidos, if I had introduced myself a year ago, I would have introduced myself as Lockheed Martin. We were a part of a large group that was spun off and combined with Leidos. So the group that I have that does software or systems and automation for the FAA is the same group that's been doing automation for the FAA for many, many, many years: ERAM, TBFM, time-based flow management, TFDM, and such. So we are now Leidos, and so those are the guys that in case you were wondering where we came from all of a sudden. Where we are today, I'm going to ask each of you guys. I've got these rock stars on this panel with me today. They are the world experts. We got to see Dan and Steve get an award for the work that they did and that time, speed, spacing recommendation, which was outstanding. We're going to talk about time, speed, and spacing, but as Andy said, it's a little bit of a bait and switch when you look at the description, because really time, speed, and spacing is just an enabler, and it's an enabler of performance-based navigation. And so what you're really going to hear a lot about is performance-based navigation, because that indeed also is the goals that we've been talking about in the NAC, certainly since the Next Gen Integration Working Groups were put together. We want to get to a point where we have the efficiency of VFR operations with the predictability, or as the first panel who teed up the whole day, I thought so effectively, said, the reliability. And so how do we get to that? I think the nirvana of that environment is everybody's on these nice optimized profile descents. We have everybody on a set of procedures, and we're metering. We are basically absorbing delay way back, hundreds of nautical miles back in en route airspace. We're hitting those meter fixes, and we're doing coupled scheduling. We're creating just the right little slots as flows come together. They zipper in, and then we're just flowing right into these to the runway. That's their nirvana, and I think what we're going to talk about today, and what I think the report that these guys came back with, lickety-split time, right? The tasking came in December of 2015, and you guys came back with a report by October, and a pretty comprehensive set of recommendations. What we're going to talk about is how do we get from where we are today to that environment, and that's the perfect environment. We're not necessarily ever going to get to perfect equipage or any of that, but how do we take those steps to a very much non-time-based NAS to a time-based NAS, and how do we do that incrementally, both near-term recommendations and far-term? So let me first ask each of you guys to introduce yourselves quickly, and then we're going to start right in on some of the discussions. And I think we're going to try to, I'm very mindful of the fact, first of all, we started late, Andy. And I'm on, this is your critical path to the happy hour, and we've got nothing, we got no saving the whales, cool drone, whale spit stuff to talk about here. It's just time, speed, and spacing. So we'll try to keep you awake in the last panel of the day, even though we're not the cool drone guys. So anyway, let me let you guys introduce yourselves.
My name is Jeff Woods. I'm one of the NATCA representatives based in DC. I work at the program office. I'm actually based out of Houston TRACON. I've got en route, tower, and TRACON experience.
Good afternoon. Bruce DeClean with the FAA Flight Standards Service, Next Gen lead in Aviation Safety Organization, and just pleased to be here.
Steve Fulton working for Sandel Avionics. We're building a new cockpit retrofit system for the lower end of the market, the small turboprops, working turboprops, small jets, light transports. And as we're architecting that cockpit system, the part that works on the airplane, of course, is really interesting to us, particularly a 4D path computer. In addition to that, I also have the opportunity to fly. I'm really fortunate. I've got 2 companies that allow me to work for 2 separate companies. I mean, they agree that I can work for each company. So that gives me an opportunity to fly on the weekends as a line pilot for an airline. And that's a real opportunity just to see what's going on in the airspace. And I bring those into what I'm doing for Sandel, but also in things here at RTCA. As Dan and I were working together on the Time Speed Spacing Task Force, I had a lot of just things that I was curious about, that I was seeing out on the line, that I had the opportunity to ask questions and go back and forth. And it really helped, I think, move us forward and bring those perspectives in.
Thank you, Fran. My name's Dan Allen. I'm the Managing Director of Flight Technical at FedEx. Been involved in metering and timing of aircraft for almost 20 years, the 10 years at FedEx in my previous life at the FAA. So it's a great passion of mine. I was really honored to be asked to co-chair this committee, and I'm looking forward to sharing some of what we learned with you today.
And good afternoon. My name's Kirk Holick. I'm a newer face to the RTCA community, but incredibly humbled as I look out across the representation of the industry that's here. Excited to be joining these guys this afternoon, and I'm kind of bringing the avionics side of the house as well, along with Steve. Been working product development now, primarily for flight management systems for most of my life, I guess I should say. So looking forward to it.
Great, thanks. So Dan, can you start us off with maybe some of the near-term recommendations out of that report, and how do we get on the pathway to where we're trying to go with time, speed, and spacing?
Yeah, I think it's important before we start to talk about what is PBN and why does it need timing? And why does timing need PBN? Because that's kind of a catchphrase of ours. You can't time without PBN, and you can't do PBN without timing. So as the previous panel said, we have some success with OPDs, but as you get closer to the runway, particularly the RMPAR, we have very limited success in having aircraft stay on those procedures, and that shouldn't surprise us. PBN is a defined path that you present to the FMC that it's trying to execute on. For over 50 years, the controller's primary method of spacing and sequencing aircraft is this magical thing called a vector. You kind of come in anywhere you want, anytime you want, and there's this person, a professional at the end, that'll fix that by vector and absorbing delay through this vector. And now we're asking the controller, don't do that. Leave them on these defined procedures. So how do you do that? You have to time them. The reason we are seeing limited success today is because when you have multiple aircraft, we don't have any really good way to know if an aircraft is timed or not timed far enough apart. So our group in the near term, that's prior to 2020, looked at some of the tools that are on the precipice of being deployed that could assist with this. You heard about GIMS a little from a couple of the panels. Ground interval management's an en route tool and a piece of traffic management advisor, TMA, that'll allow the controller, give him some more information, that controller more information on whether the aircraft is timed or not, and supply speed cues. That is in test right now at a couple of en route centers, and the plan is to deploy that across several other facilities prior to 2019, 2020. Small number of facilities. Along with that, you've probably heard about TSAS, terminal sequencing and spacing. That'll be the first time we get the terminal controller involved in spacing the aircraft. So you course feed them with GIMS and you hand them back over to the terminal controller to where when aircraft are sequenced together, as Fran said, I like that term, they zipper together if it works and functions well. So that's two of the tools that are in the recommendation. The beautiful thing is that we're in nice alignment with the FAA on that. They are working on the same exact plan. TSAS went from tech transfer from NASA to investment decision really, really quickly, especially in the government world. And the reason why is it has great promise. It looks like it's going to work. So over the next year or two, we're going to get a lot of information from the agency and some of the testing that'll go on, whether this will really work. We've asked the FAA in this report to keep the number of facilities we do an early launch on small, because we want them to focus on adaptation. This is going to be hard work. Hard work. And the last thing we want to do is roll it across a whole bunch of facilities and have it fail. So those are two of the highlights of what we're in the near-term report. The other one is to use some capability that's been on the jet for a long, long time, and that's required time of arrival, or RTA. We've asked the agency to look at, can we use that capability to course feed, apply some speeds prior to top of descent to allow the downstream controllers a better opportunity for success. So I think I'll stop there. Those are the three major ones we've asked for. And
Okay.
Go.
Yeah, I think, and one of the other recommendations was talking to culture change, and you know, how do we change to a time-based operation? Because taking in a new automation tool and just using it within the context of the existing operation isn't necessarily going to gain the benefits that we're really looking for. So, Bruce, if you can talk to us a little bit about what the FAA is doing. It's quite a challenge.
Yeah, it is. And this is really probably the most potent aspect of the recommendations that we've really been thinking about and figuring out how to turn into action. So what is culture? I want to focus on that. So values drive behaviors, drive results, right? And this isn't just an FAA dialogue. This is FAA and industry. What is it that we value? When you think of what is the best pilot, what are the characteristics that you think of? You think of somebody who is really tactical, great flying skill, can manage all sorts of real-time failures on their own. You think of the pioneers who can manage those situations. That's what we value when we say the best pilot. We tend not to value someone, we tend not to place inherent value on, the ability to hit their RTA, as Dan talked about, or their ability to stay exactly on the track that had been published, which we take for granted. We take those core skills for granted. When you think about a controller, what do we think of as, what do we tell the workforce internally? What is the best controller? Well, the best controllers are the people who maintain pressure on the runway and have the highest throughput with minimal disruption. That's really what we value. Those values drive behaviors, and that drives everything that Dan described in terms of our decades of experience, where we do delay absorption in the terminal area with vectoring onto an ILS. That's how we do our business. PBN requires us, if we're going to really embrace PBN through to fruition, requires us to solve that problem a different way through time, speed, and spacing. That requires us to value, and you heard this morning in the first panel this morning, in a little bit of the Northeast Corridor. What is valuable? What are the metrics in that conversation? There's been some really good dialogue about predictability as a metric, reducing the variance, right? What does that really mean? The greater value we place on that, the more we start to think about the problem a little bit differently and say it's not about slamming the next airplane in right right behind the one in front of it. It's about that predictability and that ability to adhere to the plan that was set up maybe 30 minutes ago when the airplane was further up in the arrival. So that's the change. That's the shift. That's hard. I mean, we've instilled in the internal workforce and the external workforce and all of our training a totally different mindset. So how do we embrace that? So I'm on the aviation safety side of the house, but I really have to give a lot of credit to air traffic, who's really leaned into this. They've done a lot deeper socialization within the air traffic services. So the executing arm of air traffic, in terms of really understanding what is this conversation, what are these values, what is this change we're talking about, and how does it change sort of a day in the life of a controller. And the same has to happen on the industry side in terms of what does that change look like. Another key thing that the FAA has done is look at this from a leadership standpoint and say, how do we make sure we have effective leadership in the right places, and has identified some key personnel can help deploy it. So a great example is my colleague Rob Hunt, who has moved over to be in mission support services and really focus on how do we take the set of tools that Dan talked about and integrate and deploy them at a particular location in a way that really impacts the operation. So it's a tremendous amount of work to be done, and really it's for you as well.
Yeah, and your report, I mean, Dan and Steve mentioned the human component, I think is how it was called. So that would be more than just the controllers. I mean, we all kind of want to throw this on to the controller, but it's the airspace adapters figuring out, right, where the meter fixes, meter points, how are we going to run the operation? It's pilots, and it's certainly the traffic management folks. So Jeff, tell us your perspective on the culture change, the changes that are coming.
So one of the things I like what Bruce was just talking about, and we agree some of the times, not all the times, but most of the time, is it's not just about air traffic, it's not controllers, it's not pilots, it's the whole system. It's actually understanding if a pilot keys up and asks for a shortcut, what that does to the system, and a controller approving it. They don't understand that that pilot or that airplane could be in direct conflict now with somebody coming in from another side. So understanding that overall aspect of what we're trying to accomplish with trajectory-based operations, time-based plus PBN, understanding what we're trying to accomplish, that is the biggest thing. From a headquarters level, it's one thing, but now how do you filter that down into the actual line controllers and line pilots and getting them to understand what we're trying to work towards? Because it's nothing saying that what we do today in a facility is wrong, because we don't see a lot of no-notice holding like we've done in the past. We've managed flows a lot better than what we've done in the past. We have continuously made progress in the NAS about making things more efficient. But what we're talking about with the shift to TBO is a truly different environment. But we also have to take what's going on in those facilities and understand what's happening, understand how they're using the tools, understand how the operation has to implement those tools and integrate them into what they're doing. That's not even just from an ATC perspective, but that's from a cockpit perspective as well. It's looking at this bigger vision and getting the workforce to understand, and not only understand it, but buy into it. With that, you also have to have those support mechanisms in place. You have to have the ability to deploy a tool, but at the same time sustain that tool and be able to address issues that we have with it, because you're talking about something that has to deal with a very dynamic situation every minute of the day. It's always going to change, whether it's weather, whether it's an aircraft that's a little heavy on final and we need to extend them downwind, whether it's a different controller working finals than the one before that is not afraid to run them a little bit tighter. The other one may want to run maybe just a little bit, a half a mile, a little bit more room. It's taking all those human components and factoring them into that equation to where we get the repeatable, predictable environment that we're looking for.
That's great. And I think you and I were talking before about where you guys came in and looked at some of the ERAM data, I guess, and looked at Seattle, and that's certainly, I think, a TSAS key site. So what did you find there, and where do you think the challenges, as an example, are going to come?
So as I look to my left, greener skies just will not go away. But it's greener skies has taught us a lot of things, as all the projects we've done. I mean, and it's Seattle right now functions in that older mentality of how we work airplanes. We took a lot of the delays, we held them down low, where we use delayed vectors and down at lower altitudes instead of trying to push it back and actually manage flows further out from the airport. And the facility is doing exactly what they thought was the way that industry wanted to flow that airport. The problem with that is everything's changing. So how do we go in there and have those conversations? Steve, you and I have talked about this till we're blue in the face. How do we get in there and basically get to that top of descent on that OPD, issue the descend via, and then just let the airplane float? Well, you got to manage the flows further out. But when you take an environment that has continuously kept airplanes close into the TRACON to keep pressure on those runways, that's a different world than what we're talking about. And understanding that vision is the biggest thing. We've been out. In fact, tomorrow afternoon I got to go out to Seattle again, or not Seattle, but San Diego. Next week we got to go to Seattle, and we're having those conversations again, talking about what we're trying to do going forward, because it's about what the operation's doing and how do we get them out of their current mentality. Because you talk about Seattle, but LA runs a certain way. Houston, Dallas, Atlanta, New York, they all run it a little bit of a different way. Can we get to some sort of a baseline system, and now let's start factoring in those little nuances we have at each airport based on runway configurations, concrete, other constraining airports that might be in the near vicinity and stuff like that. It's got to look at that whole picture. It's not just about one thing in that geographical area. It's about all of it.
It is, and it's interesting because we now have extended metering, so you really could look at adjacent center starting, the metering basically for something that's not even in their center's airspace. That's a rock the world, right, kind of thing. Now, how do we even get those folks together to figure out how to assign the delay absorption back in an adjacent center lining up? So it's.
And I think that's the key to this. We're talking about a capability. We're not talking about an individual tool. We like to talk about TSAS. We like to talk about GIMS, but it's about that suite of tools to be able to identify what is the right tool for that situation. And it could be, it's going to be a different combination of tools on how you put it in there to try to identify what the problem is and how you're going to solve it with it. So.
Great. So, Steve and Kirk, how about the avionics side? How are we doing on that, at least for the near term?
So great question, and I find it interesting. During the task group, we talked a lot about collaboration and this topic of systems and how one particular part of the system doesn't enable you to do this time, speed, and spacing operation without the whole thing there. So on the aircraft side, when you look at PBN capability, what's there in the RNAV and RMP worlds, I think the FAA in their NAV strategy document for 2016 outlined some equipage numbers, even to the tune of 80% RNAV capable on even Part 91 operations, and it increases through the scheduled operators. And so that's promising. It's nice to see that, and that those procedures are out there. I think Dan kind of alluded to the 2020 timeframe and some of what we're talking about for RTA. There is further capabilities that are employed. I'm not going to quote any numbers. I don't know them off the top of my head, but in a lot of those operations, at least scheduled operations, there is RTA capability now. There's some discussion back and forth and relative to performance and how the airplane can act and respond with, and Jeff and I know we're talking about that even earlier today about trust in the system, and I think that's where some of the earlier panels and the discussions on collaborative and specs and standards being written to help drive that uniformity is really going to help even on the RTA front.
Good. Steve, anything?
Yeah, I think our biggest challenge still with equipage is we've got so many airplanes that have been out flying for some time that they need to be refreshed. How can we do that affordably? Obviously, a lot of us are looking at ATSB right now, being compliant with ATSB, and it's a good time to perhaps not just check that box, but take care of things like the lack of radius to fix capability in the FMSs and the ability to draw them on the map, as well as VNAV. So RF and VNAV, if we could solve those two things, I think a lot of what we talk about as far as mixed equipage would be less of a concern. There'll be new things, of course, from time to time, but these would be two heavy hitters that we really could do a lot to help ourselves if we could address that.
That's great. So Steve and Dan both. Yeah, I mean, I don't know if any of the other, you guys are pilots other than Steve and Dan?
Yeah, I
okay,
can
just
talk
you guys.
a little bit.
So what about
Yeah.
the pilot culture change? Is
Yeah.
there one?
I can talk about it.
Okay, you can talk about it. I can talk about it too, but I can't do it.
There definitely is a pilot culture change. We're asking pilots, just like Dan was describing, asking controllers to leave the airplane on a path. Leaving the airplane on a path while you're being given speed changes is something new. And the automation that we have right now, whether it's the flight guidance, if we're going heads down and making the flight management system be where we enter the changes, it's not straightforward. And also if we have descend via clearances where it's descend via accept and there's an altitude change and then maybe a speed change later, those layers of complexity are problematic. Problematic, number one, because we don't have a lot of experience as a pilot group doing that, so we need some practice. So to the extent that we can implement these things earlier and we get the level of experience moving in the direction that can help the learning curve, that would be great. But also maybe there's some architecture changes. When we're in VNAV, particularly on these established on RMP turns to final, sometimes when we're changing the speed on some of the airplanes, we're losing the VNAV path and we're going into a speed mode. And so the airplane now is no longer following the path, it's pitching to fly a speed. And it's really subtle. The changes, those mode changes are very subtle in some cases, and the pilots can miss it. And so it may require some design changes, training, experience, but it's definitely a big deal.
Interesting.
I would just add, I mean, so it's a community I interact with a lot.
Right.
The workload associated with following the vectors that Jeff gives to intercept the ILS is very, one, it's very familiar, we're accustomed to it, and two, it's the workload is not particularly high in the flight deck. Mm-hmm. When you talk about changing that to an OPD arrival with a star with multiple fixes following lots of things, and I got altitudes changing, I got, assuming the controller leaves me alone, I have speed changes occurring on the way down, all of which heads down on this little box that's trying to display this to me. The workload goes up rather dramatically, and so sort of there is a shift there on the flight deck that's pretty significant. And I would highlight from a safety standpoint, there are some concerns about that. We just issued a SAFO again earlier this year associated with basic pilot skills and the importance of pilots being able to really fly an airplane and not get so lost in the automation that they forget how to fly the airplane. We have insight into in-flight upsets where flight crews get distracted and they get heads down, and so there's this balance that has to be achieved between sort of the traditional responsibilities in the flight deck and these additional responsibilities, which is very analogous, I think, to the challenges that Jeff's colleagues face.
Yeah.
There's one other piece that is going to be a culture challenge for the flight deck side, and that is this idea of having a clearance that's temporal, not a lateral or vertical. We're cleared via headings, we're cleared to intercept courses, we're cleared to climb or descend to an altitude. Cross a fix at a time, that's something entirely new. And the tools we have right now, again, have been implemented and yet have not been used. So we've had in some airplanes RTA functions since the mid-'80s, and yet we haven't really used them, I would say, in anger. I've had some experiences. I'm always asking when I'm out flying, I'm saying, hey, instead of getting this vector, getting the speed, hey, what time do you want me to cross that fix? I'm just dying to try out this thing that we've had since 1980s. Once in a while, I get a controller who will tell me to cross this fix at that time, at a given time, and I've done pretty well, but one time I really muffed it, and the reason I did is because I was reading the time error. The time error is in tenths of minutes, so every 6 seconds I get it. So I'm working to null this error out, and I keep speeding the airplane up, and the time's going the wrong way, and it dawned on me, oh shoot, I should have been slowing down, not speeding up. So the numbers were getting bigger or smaller or something, but it was, there's a lot going on and so forth. So the human-machine interface on that RTA page on this particular device I'm flying is a little lacking. There could be more graphical tools, better presentations, maybe just a simple speed. They fly the speed to get that. But anyway, it's these things are all going to be new, and the earlier we get at it, get started on these things, the more we're going to learn, and the quicker we'll get to the solution.
So one of the things on my side I want to kind of piggyback off that, because that's a really good point, is so while you're figuring out how to hit that time, speed up, slow down, left, right, now me as a controller is watching it from a mixed equipage standpoint, because I could have somebody behind you that may not be flying RTA capability. Now I've got to be able to anticipate what that airplane's doing. And that's some of the things that we also need to work on, and we talked about till we're blue in the face as well, is understanding how the intent on what the airplane's going to do to make that time, how do I adjust it for that mixed equipage scenario that's also around there. So there's a lot of moving parts to it, and we're already starting to dig into it, which is a good thing, but it's we definitely got some work ahead of us to figure out what that's going to look like.
Hey, Fran, one other comment. I hate to admit that I'm a pilot, but that's usually just general aviation, the famous $100 hamburger run, so nothing quite to this level, but with building avionics, you do get a chance to do a lot of flight testing and fly with a lot of crews, and I tend to agree with Steve. That shift to a time-based clearance will be something that crews are going to need to understand. There's a change there, but when we talk about the rest of the complex clearances, fortunately there is that datacom piece that's out there that will help with those complex items. Descend via clear to direct, et cetera. So I think the work that the special committee is working on, and some of them recognized at lunch today, was an integral piece to this as we continue to move forward.
That's good. So Bruce, you're on the safety and regulatory side, and we're talking about safety here, really, when it comes down to it, as we make these changes. And so how is that side of the FAA, how is your side of the FAA engaged in assessing, say, new procedures, or what are you doing there?
Let me sort of address more broadly, why is this even important to us? So other safety risks, runway excursion and CFIT, have fairly high correlation to unstable approaches. So both of those remain important risks. We have this great collaborative forum, commercial aviation safety team. Very first recommendations that came out of that group in the 90s were associated with CFIT risk and the value and importance of stabilized approaches. And we have been pursuing how do we get everybody to be able to fly good, energy-managed, stabilized descent ever since. PBN, as we have heard it discussed, is a fantastic way to get a great energy-managed descent. So with a well-designed PBN procedure, you can get the efficiency benefits that are associated with that descent, but you also get a pre-planned path that's compatible with the airplane itself. The aerodynamics, you're not coming in too fast, you're not trying to deploy speed brakes, you're not trying to change altitudes late in the approach. That is tremendously attractive from a safety promotion standpoint. So we have done a lot of things incrementally over the years to continue to pursue that goal. So all interacting with procedure design and characteristics. My office is responsible for basically the building code of how you design procedures. And we take the lessons learned and try to apply them to new procedures so that new procedures are more compatible with aircraft designs and aircraft descent rates and promote that. And this last little piece, this transition to timing, really, as Dan said at the beginning, is essential, because without it, what happens is we get this great procedure in there, and then in the real world, Jeff and his colleagues have to take us off of that path and dump us somewhere else. And when you look at the safety information, you look at the stabilized approach information, a lot of that unstable approaches, they're occurring in VFR days, not instrument days. It's not about the instrument days from a safety standpoint. It's about how do we get stability on the VFR days. We're only going to get that if we can fly those really great tracks on the VFR days. And we're only going to get that if we can give Jeff the tools and the capabilities and the culture change to let us be on those tracks and maintain throughput on the VFR day. So that's the logic chain that puts us all together of why, from a safety standpoint, this is such an important initiative.
All right. Anything else, you guys, on the near-term recommendations, things we need to really look at right now just to achieve really utilization of the tools that we already have or are soon going to be out there? Anything else?
I think probably the biggest thing is it's really about managing expectations about what we're trying to accomplish. And it's not even from an ATC perspective, it's from the cockpit. It's across the whole thing, because with what we're trying to do, we've got a lot of dialogue going out there, but we also have a lot of dialogue going on over here and over here and over here. It's really understanding, and RTCA does a good job of pulling everybody in to have these robust conversations about what we're trying to do. But it's really managing expectations, because I hate it, but a lot of the canned responses when somebody asks me a question about what can we do and everything like that, it depends. We've had this conversation about RNPs in Denver versus Seattle on the dynamics on how easier it is when I have over 16,000 feet between outboards, and I got Seattle, I've got 2,500 feet, and I've got 3 runways crammed in that 2,500 feet. They're very different dynamics, and managing those expectations about what we can do is very site-specific as well.
Okay, great. Well, let's move on to, because there's a lot more in that great report, and talk about the medium and far-term recommendations. So Steve, tell us about that.
So the mid and far term, the beginning of the mid is just a continuation of the near term. And Dan did a really good job of describing how all these tools layer together. We've got the TBFM, which is that underlying platform that provides the timing function, and then this extended meeting with GMS that connects with TSAS. There's another piece that we really struggled a lot with in our discussions, And there's a lot of emotion and passion on both sides around this. But we put a provision in the report that is really a marker for some results that were going to be collected from a flight trial, and it just happened earlier this year. And then a final investment decision will be made in 2019 around this last piece, which is the flight interval management spacing. In all of the presentations and the work we did, it was clear to us through the data that the flight interval management spacing, or FIMS, was the tool that gave us the ability to reduce the inter-aircraft variance or standard deviation better than anything else. And that was a little bit disconcerting to many people in the team, because there was some preconceived notions and really some desires to avoid the costs that are associated with that. But with the data that was presented, at least the analytical data that was presented, it seemed like something that we did need to consider, but yet not commit to it until the results of the flight trial were fully digested, which will be happening in the future yet. So with that last piece, FIMS, that will be that complete set of tools. And then there's the non-traditional application of CRDA and the RTA that Dan mentioned that would also be part of that midterm. There was an understanding, though, that as we look out into the more distant future, it's really important that the airplane be connected to the ground. So much of what's happened in our early deployments, there's been some examples where we've had airplanes established on RMP procedures where the procedure that they're flying was actually the incorrect procedure. And so someplace way back in the flight, prior to top of descent, presumably, a procedure was loaded that became a latent failure that was undetected. And it could easily be detected if the airplane was sharing its trajectory, its intent with the ground. All of this could be machine-to-machine coordinated. And there's a lot of value with the ground automation taking advantage of what the airplane knows, and to some extent the airplane taking advantage of what the ground knows, and that shared view of what the trajectory is a big part of that mid and long term. And that involves having airplanes that are capable of producing high fidelity trajectories and sharing them. And it also involves having the ground automation that can receive those and make use of them in some sort of an analytic sense. So it's not a human reading it, but the machine-to-machine coordination. There's a question about the data comm standard. We're in a big push right now. We're getting a lot of near-term benefits, getting FANS 1A pushed out to more airplanes than what we had seen previously for the reasons that have been talked about already. But there's a transition out there about the mid-20s where in order to do this higher fidelity exchange of trajectory, it takes a different data comm than what we have in FANS 1A. And how that happens, how that transition occurs is not really clear, but it's something we talked about. We had a lot of presentations around that, but it's going to be a significant burden because a lot of the components that are in most of the airplanes today that are equipped with FANS 1A will have to be replaced to be able to get the advanced datacom capability, is my understanding. So I think that's maybe a good introduction.
No, that's great. And I guess, and it was really the prior panel that would have addressed, one would presume ATN B2 or whatever standards would need to be established that then you all who produce the avionics boxes can go build to such a thing. But I know, we also on the ground, our trajectory software, can work much better. And we've done research with GE.
Yeah, exactly.
To look at how intent and how sharing that trajectory can improve situational awareness on both sides.
Yeah, let me talk about that actually. This is a really important. So GE and Lockheed Martin,
now Leidos.
On their own.
He's not a GE.
Yeah, I'm
and
not a GE either. But in the past, GE and formerly Lockheed Martin had done this work on their own dollar. They had made their own investments of having the FMS that's in the 737 connect with the en route automation. en route airspace modernization of the ERAM
Right.
capability, and that's part of the roadmap. You're
Yes.
going to be building that work that was done in research now is going to be part of a work package that's released. So the ground piece is coming along, as we've seen.
Yes, yeah, that's great. That's great. Good. Anything else on the long term? Anybody want to say?
I could probably add something to
Sure.
the flight deck interval management ATSB in conversation. And I made this comment at the NAC. Operators have no appetite for equipping for something that isn't going to be fully utilized. So these are some really important years right now on getting an understanding of, does the capability work and how are we going to use it? So as Steve mentioned, there's a flight test that just occurred. There's a couple of HITLs scheduled next year. If you read our report, it may appear like we're punting on a recommendation on this. But back in 2012, the ATSB and ARC said the business case wasn't fully mature yet. That needs to happen between now and when the FAA intends to go to investment decision in 2019 on this. So that's our recommendation, is let's gather up this body of work that's occurring right now, look at it again here in maybe a year and a half, and make a commitment both on the FAA side and the industry side that we're going to either go or not go. And we need to have the maturity to say, if some of these other tools, ground-based tools, are getting the job done, why kill that bird twice? Because it's expensive.
No, that's good. That's good. So all of us, probably many of us in this room, voted on the Northeast Corridor priorities over the last couple of weeks. So how would that factor in? I mean, when do you see an ability, we just talked about all the culture change both in the cockpit and on the ground that needs to happen. When are we going to see some of this in the Northeast improve the situation in the Northeast Corridor? And I'll start with Jeff, but anyone can jump
So
in.
you really want to open that can of worms?
Well, I don't know.
So, the key to the Northeast Corridor right now, there's already things in progress that are going on up there today. I mean, we've got work right now, the Atlantic coast routing, from New York area down to the Caribbean are being worked on today. We've got PBN procedures that are being worked on. A lot of that is already in progress. In fact, we actually had the New York facilities reach out to the TBFM ops team and say, hey, we want to start playing. We want to start getting into this. But, obviously, they talked about this on the last panel. The first obstacle they ran into was staffing. That was the first issue that just came up, and it was a little difficult to overcome, but we're starting to work around that again. We've got some other things that we're looking at right now, some other tools in the capability right now that we're looking at deploying. I think we're probably meeting more now on the NEC than we did on time, speed, and spacing group, and I thought we were meeting a lot on that group, but NEC, it's between the internal stuff and the NAC subcommittee, there's a lot of churn going on. But I think it's important not to forget what's already going on out there, because you have to take a win on whatever we can get it. But at the same time, I think Steve Dixon talked about this. We can't boil the ocean with New York. We've tried to fix this so many times, but I think the biggest thing around the whole, what do we mean by fix? What do we think that's broken? I think we really need to understand that as an entire group, about what we're trying to go in there and accomplish. Because if we just start throwing things up on the wall and see what sticks, I'm not sure anybody's going to be happy with the end product. We really need to get down and talk about what we think is broken that we need to fix in New York. Because let's face it, 3 major airports and throw Teterboro in the middle of it, then you got islip and keep going down the list. That is a very complex scenario. And plus, you got a lot of airports that don't have a lot of concrete, and they're probably not going to get any more concrete. And everything that starts that we're working on PBN-wise is all driven on that concrete, because we can reduce separations, we can put in wake recat, but if that concrete can't handle more airplanes, it's a lot of work that's not going to show any results. So I think it's managing those expectations about what we're really meaning about fix.
I would just add, as the group works through the details, I think that that gets back to my earlier comments on the values. There is not much unused capacity in New York. So what are the values? The value is throughput, and what is the risk tolerance of throughput against predictability? And that really is going to be the challenge as the group works through all the various possible initiatives and sort of how do you balance that. Because there really isn't any unused capacity, so that's not the conversation.
Right, which says efficiency-wise, capacity-wise, it's working
Well, and I think one of the things around that, it's maybe a little bit more about communication, because we talk about weather up there, and let's face it, anytime we mess with Mother Nature, she tends to put us back in our place, and we got to really keep that in mind, because those facilities do a good job of dealing with weather on a daily basis, how to work around it. The pilots do their part in it as well, but maybe it's a little bit more of a communication platform about how we're going to roll in and out of different swap plans and stuff like that, making sure everybody's on the same page. So it's truly looking at all this from a holistic standpoint, figuring out what we need to fix. Because I agree, Steve, Bruce, we looked at that at the beginning when this really got teed up at the NAC. We're hitting arrival rates. The controllers up there are hitting arrival rates on a daily basis. In fact, we saw some data that was pulled earlier on in probably about the mid-2000s. They are between Newark, LaGuardia, and JFK, they are the top 3 efficient finals in the NAS right now about hitting arrival rates when they're supposed to, and separation on finals. So we just need to make sure we're understanding what we mean by trying to get more capacity out of something that may not necessarily be there.
That's good. Andy, do we have anything?
Okay, you have one of the things I would recommend maybe is that you give an assignment to the ATSB panel tomorrow, because we've probably got about 3 questions that are in the vein of FIM and operator equipage that I think Dan was saying, there's some hiddles and some work going on. But I guess one thing I would say is, if anybody wants to address that, give any advice to the ATSB panel tomorrow as fodder, that would be welcome. And then the one other question that kind of sums up some of the themes of the questions is the big picture on TBO. Is that really attainable? Is, the overall perspective about that as well?
Do we have an hour to talk about that? No. Trajectory-based operations?
I'll grab some thoughts on that at least. I go through waves of optimism in this sphere, and I have some optimism right now. Policy, procedure, decision support tools, environment. You heard a lot of commentary on the work being done from some of the other groups today. We've been out of sync in that area for a long time, but the equipage is getting there now. We're getting certified to use it. The procedures are being designed. The policies that allow us to use it are coming into place. Established on RMP is what I'm thinking, to allow us to use PBN close into the runway, closely on parallel runways. And this is all going to come together, and then in the control decision about a year or 2 or 3 from now. So I think just like we saw with Datacom, we saw exponential growth in the use of the procedures, we're going to see that for PBN too. So.
That's great. That's very optimistic, Dan. That's great. Anything else on the ATSB? Advice? Kirk?
To comment on ATSB, I was going to piggyback on what Dan was talking about here. Talking a little bit about where things are going in the next few years, I do then wanted to add on top of that, not ATSB. I'll let my friends on the panel maybe make some comments for that, but there is also then the the continued optimization, and there's standards that continue to evolve, and you've got advanced RMP, and we've talked about RTA and time of arrival control, and then FIM. There's already some RTCA information out there, MOPS, if I remember right, related to flight deck interval management, through a surveillance application. Then there's continued integration in the flight deck with auto throttles and things to that nature to continue to, reduce crew workload that's not available in all instantiations. So I think that stuff's going to continue to evolve, especially through new airplanes that are coming out. So I think it is neat to see it grow. And maybe I'm drinking the wrong Kool-Aid, but I tend to agree with Dan on being optimistic. So.
Well, and I think just on the TBO conversation, I think we're seeing a lot more momentum behind TBFM, because let's face it, change your acronym around for the last 15 or 20 years, and we've had the system in place. A lot of it is how we've used the system and the support mechanisms have been around that. I think as TBO is becoming the next big topic and we're putting a lot of weight behind this thing, it's actually getting out there and it's addressing what's going on in the facility today, because it's hard from a Leidos perspective to be able to know what to fix if we're not using the tool. You know, and it's using the tool how it was intended is all part of this whole culture change. It's all built into this, and we're all trying to sort this out. It's not going to be an overnight fix. We're talking about a very long process of getting in there, and it's going to be continually tweaked every day. And it's training people how to use the system the way it was originally intended, and it's understanding that vision behind what it was on how we're going to do TBO.
So I'd like to participate in a little speculation as well. I like doing that, and I do know a few things about ATSB. I find it interesting, just sort of reflecting on the day. As a community, we have a very asymmetric view of time. So this morning, when we talk about looking back, we tend to look back 10 years, 20 years, and this morning was 30 years. 30 years looking back. When we look forward, we tend to look forward 6 months, a year, and it's really asymmetric, and you sort of think about it. So when you ask about the long term, what is the long term? There's so many things that can happen in the long term. If you think long term symmetrically 30 years from now, I think the conversation we're not having is how the traditional aviation community learns from the new aviation community, and what culture change really means when industry norms start to get challenged by new perspectives and new ideas. So values drive behavior, values drive behaviors, drive results. It took me a long time to get here this morning because Americans value their independence, purchase their automobiles, and all get on the highway together. 30 years from now, my kids will be getting in the car, and they'll push the button that says where they want to go, and they're not going to be driving the car, and they're going to be using ATSB in between the vehicles to be driving 55 miles an hour on the same highway I was doing 5, with the same density of traffic, right? 30 years is a tremendously long time. Talk to the new entrant community and really hear from them and understand. It's a different world. So when we look forward, I think in the traditional aviation community, we're going to see totally different internet connectivity, which came up earlier today. I think the FIM solutions are going to migrate to be much more network-based and not just sort of this federated architecture. I need a box in my airplane, and how much does it cost? You all will solve these problems. I'm way more optimistic than they are. All of these problems will be solved, and we'll solve them together. So there you go.
With that, and 30 seconds left, anything else? We'll give everybody 30 seconds back for the happy hour. And thank you all very much. Like I said in the beginning, you guys are rock stars.